Welcome back, everyone. The Netherlands is exploring a new frontier in solar energy by launching floating solar platforms into the North Sea. These are not just simple panels placed on water. They are advanced autonomous structures designed to move and rotate in response to changing sunlight and weather patterns. Dutch engineers are combining marine architecture, robotics, and energy optimization to develop systems that can survive harsh sea conditions while continuously adjusting to maximize energy production. This innovation allows solar power generation on open water, preserving land space and offering new opportunities for large-scale clean energy near coastal cities. The floating solar islands being tested by the Netherlands are made up of interconnected circular or polygon-shaped platforms that rest on the surface of the North Sea. These platforms are designed to remain stable on water despite currents and waves. Engineers use buoyant materials like foam-filled pontoons or hollow structures that can flex without breaking. The platform's construction is light but strong, allowing it to support heavy solar panels while adjusting to motion. These islands can be scaled in modular fashion, meaning sections can be added or removed depending on energy needs or environmental factors. Unlike traditional floating solar arrays used on lakes or reservoirs, the North Sea platforms are engineered for much more turbulent environments. This means they must handle high winds, salt spray, and strong waves without tipping or breaking apart. To meet these demands, Dutch developers incorporate shock-absorbing joints and flexible mooring systems that let the island move slightly while staying anchored. Materials are coated to resist corrosion from salt water, and all electrical components are sealed in waterproof cases. The entire structure is built to be low maintenance and survive for decades at sea. The solar panels on these islands are mounted in a way that allows them to tilt and rotate. This movement is not random. Small onboard computers use sunlight sensors and weather data to constantly optimize the angle and direction of each panel throughout the day. When clouds roll in or the sun shifts position, the system adjusts in real time to capture the most energy possible. This level of active adjustment increases energy yield compared to fixed position systems and ensures higher efficiency even in the variable conditions of a marine environment. One of the most impressive features of these platforms is their ability to reposition themselves. Each island is semi-autonomous and equipped with small propulsion units or adjustable mooring lines that let it shift slightly within its designated area. This helps avoid shading from other platforms and protects the panels during storms. By reacting to wave forecasts or sudden wind changes, the platform can lower its energy profile or reorient to face less resistance. This self-adjusting capacity reduces the risk of damage and makes maintenance safer and less frequent. The energy generated by the floating solar panels is collected and managed by onboard inverters and controllers. These clever devices convert the direct current electricity into alternating current, which is suitable for the power grid. From there, underwater cables transmit the electricity back to shore, or perhaps to nearby offshore facilities. In some designs, energy can be stored temporarily in battery modules that are integrated right into the platform base. This makes it possible to smooth out fluctuations and supply energy when demand is high, even if the sun isn't shining at that particular moment. To stay in position, each island is anchored using a combination of seafloor tethers and floating mooring lines. These anchoring systems must be strong enough to withstand sudden forces from storms, but also flexible enough to allow for a bit of platform movement. The mooring lines are attached at multiple points to prevent the entire system from rotating or drifting. Dutch engineers carefully study the seafloor topography before deployment, ensuring that anchors can be safely installed without damaging marine life or interfering with shipping lanes. Every floating solar island is monitored using a remote control system linked by satellite or long-range marine radio. Operators on shore can track performance, receive alerts about equipment status, and even command the platform to enter safe mode during dangerous weather. Sensors monitor wave height, wind speed, temperature, power generation, and equipment condition. All this data is used not only for safety and maintenance, but also to improve future versions of the platform by analyzing how different designs perform under real-world conditions. Maintenance of these floating solar arrays is handled by specialized vessels that can approach the platforms safely, even in rough water. Drones and robotic arms are being tested for small repairs, inspections, or cleaning tasks. Because salt spray and seabirds can reduce panel efficiency, the systems include water jets or hydrophobic coatings to keep surfaces clean. The long-term goal is to minimize human intervention so that the platforms can operate for years with only occasional visits, greatly reducing operational costs compared to land-based solar farms. Environmental impact has been a central concern in the design of these floating platforms. The structures are placed in areas with minimal ecological sensitivity and are spaced out to allow water flow beneath them. Marine biologists are studying whether the shading effect beneath the panels influences sea life, and some initial results suggest that the platforms could act as artificial reefs. The Dutch government is also testing ways to combine solar platforms with seaweed farming or fish habitat zones to create multifunctional ocean spaces. The entire system is designed with scalability in mind. Because each island is modular, large arrays can be built by connecting individual units together. This makes it easier to transport, deploy, and expand the system without large upfront construction costs. As demand for renewable energy grows, these floating solar farms could be installed around offshore wind farms or integrated into larger marine energy grids. With no need for valuable land space, floating solar islands may become a vital component in the global shift toward cleaner, more adaptable energy systems. If floating solar islands continue to prove reliable in the North Sea, other coastal nations might adopt the model for large-scale marine energy networks. These islands could one day be linked with offshore wind farms and underwater energy storage systems to form fully integrated power zones at sea. Each floating element could generate, store, and route electricity depending on real-time demand. In disaster scenarios or major outages, mobile solar islands could be repositioned to provide emergency power near affected coastal regions. Their autonomous nature would make them adaptable in both civilian and military applications. Looking further ahead, solar islands might evolve beyond energy production into multi-use marine platforms. Future designs could support agricultural systems like floating greenhouses or vertical farms, combining food and energy production offshore. Some concepts include water desalination units powered directly by solar panels, delivering fresh water to nearby land via undersea pipes. In deep ocean deployments, clusters of autonomous islands could even serve as staging points for scientific research or communication relays. With land becoming more contested, the idea of functional energy infrastructure at sea becomes increasingly practical. If the pilot systems continue to perform well, the Netherlands could soon deploy entire arrays of floating solar platforms that work together as intelligent energy farms. Each island would operate semi-independently, sharing performance data and adjusting positions to minimize shadowing while withstanding waves and storms. The power they generate could be fed directly into coastal grids or used to support offshore operations such as desalination or hydrogen production. With increasing pressure on land use and rising demand for clean energy, these floating solar islands might become a standard feature of the North Sea horizon. Thank you very much for watching. Please like and subscribe.